Okay, so today we're looking at perpendicular lines. Back in year 9 and 10, you learned that perpendicular lines are lines that meet at a right angle. All right? So perpendicular lines are lines like the corners of a rectangle or the corners of a square, things like that. When we draw an axis, the two axes are perpendicular because they meet at a right angle. Okay? So if I say these two lines are perpendicular, how can I show that they are perpendicular? The only thing I can compare on them is to actually find their gradients. And the gradients are going to tell us the answer. So for the first one, we have got the points -3, 0, and 0, 4. For the second one, we've got the points 0, 0, and 4, -3. All right. So, if we're finding the gradient, we always write out the equation, y2 minus y1 over x2 minus x1, because that gives us a piece of credit in the assessment. So 4, call them what they are, x1, y1, x2, y1, 2, x1, y1, x2, y2. All right. So 4 minus 0 over 0 minus -3 equals 4 over 3. So the gradient of number 1 line is positive, goes that way, so I know that I've got the right line, and it's -4 over 3. This one I can already tell is going to be what? It's going to be this one was positive, this one's going to be negative. Okay, all right, so this one is going to be -3 minus 0 over 4 minus 0. So it's going to be -3 over 4. All right. How could we describe these two? If I tell you that this one is 4 over 3, what's this one? It's a negative. And what else has happened to the 4 over 3? It's gone upside down. Do you know the word for gone upside down? There's a special mathematical word for a fraction that's gone upside down, from here to here. You might have learned it way back. It's called the reciprocal. So what we say is that when lines are perpendicular, when lines are perpendicular, one gradient is the negative reciprocal of the other. Now, that's a horrible wording. So what we want is a formula. So what we say is that M1 is perpendicular to M2 if M1 equals -1 over M2. So -1 over M2 means a reciprocal. Right? So, easy version, if I have M1 equals 3, then the perpendicular gradient is what? If the first one is 3, the second one is going to be negative, good. And the reciprocal of 3 is, if I write it as a fraction, okay, 1 over 3. Harder when it's a whole number. If M1 equals -2 over 3, the perpendicular gradient is going to be positive, yep, and 3 over 2. Okay, so we just turn them over, swap the sign. So, how does this work? If we have to find the equation of the line perpendicular to the line passing through -4, 1 to -3 at the midpoint of these points. Wow, there's a whole assessment almost. So if I hadn't told you that you had to find the equation of the line, and I hadn't told you that it was the midpoint, but I told you it was halfway, all right? So if those sort of things have been disguised in a question, this could be very close to excellence if you had to unpack the problem and find out the answer. All right? So let's unpack it together. We've got 2 points. Let's label them to start off with. X1, Y1, X2, Y2. From what the word's on here, we know we're going to have to find the midpoint. All right? So the midpoint equals -3 plus 1 over 2, 2 plus -4 over 2 equals -1. 2 plus negative is -2, -1. That's good. Right, that's the midpoint. Tick. All right, that's our achieved tick. That perpendicular, as soon as you see that sign perpendicular or meeting at right angles or anything like that, or the corners of a square or the corners of a rectangle, blah, 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 we talk about gradients. We're going to find a gradient. We're going to find the perpendicular gradient. So first of all, we're going to find the gradient of these 2 points. We'll call them A and B just so that I know what I'm doing. A and B. So the gradient of AB equals y2 minus y1 over x2 minus x1 equals -3 minus 1 over -2 minus -4 equals -4 over 6. Double check. -3 minus 1, -4, 2 minus -6. Right, good. Which I could simplify to 2 over 3, but I actually don't have to, but I should probably. It's a nicer way of writing it. Right, now we've got 2 ticks. I've got achieved. All right, next job is a perpendicular gradient. So I need the perpendicular to this. So I need an M2 for my perpendicular. Equals what? Perpendicular gradient? Turn it upside down and make it positive. 3 over 2. Right? Now have another gradient. That's actually another tick for achieve, just going from there to there. All right? Putting it together, so I need an equation of a line. So I've got y minus y1 equals mx minus x1. This is what I'm finding for my answer. The point I'm using is this one, all right, because it's going through the midpoint. So -1, -1, y minus -1 equals -2/3, the perpendicular gradient. Whoops, wrong one. Perpendicular gradient 3 over 2, x minus -1. All right, it's my equation of a line. Now I need to tidy it up. Y equals 3 over 2x plus 3 over 2 minus 1, because it's going over the other side, equals 3 over 2x plus a half. Right. So, lots of little bits for achieved. Probably easily a merit if that was the answer to the question that you were given. But you're given too much information on here on how to do it. If you didn't have that information and that process was still there, it could be close to an excellence or a low excellence grade. All right? Okay.